Good morning, good afternoon, and good evening. Welcome to UPSC with VAR. So, we're going to see two topics again today. First one is NISAR, and the second one is satellite communication technology. Hey, wow! See how the satellites are rotating? I think it's interesting. Next, what is NISAR? NISAR is a joint project by NASA and ISRO. What do they both combine into? They are going to send something called synthetic aperture radar. What does it do? It will go to space, click images of Earth, and send it back to our database. Then, why are we actually okay? First, let's see the applications and then we will see why are they collaborating. So, for communication, as you know, we will be using radio frequency. We will also use L band and S band here. Okay, it is right now the launch is expected on March 2025. Initially, it has been on 2024 January, but it has been postponing due to some technical issues. What is the purpose of this satellite getting into space? So, it is for Earth observation, for climate studies, disaster management, and ecosystem monitoring. Okay, so what does actually it do? Okay, give me yeah. So what happens here is the sat the satellite is placed in the LEO, and then it will actually send the radio waves to the Earth, and based on the written time, it will, based on its computational powers, it will analyze and tell you whether there is a forest there, there's a drought there, there's a river there. Like that, it will tell you. Okay, so applications in what actually we are looking for is for glaciers, ice sheets, disaster managements like tracking earthquake, floods, landslides, and then our forests, and then coastal monitoring like the soil moisture, how is water resource tracking, etc. etc. So what happens here is it is a dual frequency radar. As I told, L band and S band as both are being used here. It can detect very small changes. Okay, even a millimeter change also it can detect. So what this does is in 12 days it can map entire globe. Okay, so for every 12 days we will be getting new data, so it will help us in studies, studying basic how, what, where, what's happening, how is everything changing, etc. etc. Okay, so what happens here is the NASA is actually giving the L band, GPS, uh, information recorder, and the payload data system. In coming to ISRO, it is giving the S band, GSLV, and the spacecraft. Okay, so after commissioning period, like commissioning period in the sense the time the rocket started here, went to the orbit and is actually set and it start um, its operations, it is called commission period. Once the commission period starts, NASA is going to use L band for 3 years, ISRO is going to use S band for 5 years. Why NASA is using L band and why ISRO is using S band? NASA is using L band because it want a broader perspective of what's going on around all the world. in the sense how things are depleting, etc., etc. But what India's main aim is, it want to understand how our country is progressing, okay, how borders are progressing, how our rivers, how our maritime boundaries are, everything. So we need a more clear picture clarity. So that happens in S band, okay. So we are using it for 5 years. You can ask why NASA is using for 3 years. It's it only want it for 3 years. If it want in future, it might expand also. So this is how it is. So we also saw applications, right? And then, as I told you, it is like it will send the radio signals and it will receive the radio signals based on the latency, that is the amount of time it reaches and penetrates back. It will detect the surface, right? So even in night, even in bad weather conditions also, this will help a lot. So that's it for your NSR satellite. And now we are going to see about satellite communication technology. As we also read in quantum technologies, this is also a similar type only. So what is happening here is, it will enable communication via satellites. So right now we are using towers and all for our communications, right? When you call somebody through tower, your this thing, your call will go, it will get connected like that. So this satellite communication technology eliminates the uses of towers basically. The physical structure which is there on the earth can be eliminated and you can directly contact your other person. So applications are telephony, broadcasting, navigation, and disaster response. So why is this actually there? Okay, so recently China has produced a satellite communication technology, which is a series of 3 satellites basically, to produce satellite communication technology. The name there is Tiantong 1 series. Okay, Tiantong 1 series. So with this, there is no need of tower in the earth. It will directly give you the communication. Okay, then with respect to India, what are the advancements we are doing? So according to India's advancements, Telecommunication Act 2023. So Telecommunication Act 2023, what it does is, it will actually it is actually giving out the satellite communication rights to companies, that they can get the spectrum without auction. Why? It is encouraging satellite communication, because with auction you should actually have a tiresome process, that administration process, everything will be there. So that and all is eliminated here. And the second one is, uh, it is also giving GMPCS license, that is global mobile personal communication by satellite. For they are giving these rights to companies actually. Why are they giving? In order to promote global satellite communication. Then earlier Bharat Group and Reliance Group also actually took these licenses. Okay, so right now, what are the global things which are available is GSAT satellites and OneWeb collaboration. And see, this and all we right now only we saw, no? Why do we need satellite communication basically? So these provide connectivity in remote and rural areas, even during disasters, natural disasters also. When the ground infrastructure fails, this satellite communication can be a key for you. It will enable secure communication and defense and intelligence. It will facilitate broadcasting and global telephony. Coming to challenges, now if you want satellite see, for now, here only in on the earth, terrestrial towers are more for communication. What if you are increasing your satellite communication? The rockets, we will have to be sending satellites there only, no? Then space debris will increase, orbital congestion will increase, because there will be only one single orbit. If you go keep on adding satellites, it will get congested, right? And high latency in geostationary satellites. So for satellite communication, this Tiong 1 series is going to be put in the geosynchronous orbit, okay, which is at 36,000 kilometer. Why are we putting here? Because it is approximately, the orbital time is 24 hours, that is 23 hours 56 minutes, 56 minutes, some like that, okay. So latency means the time where signal goes and comes, high latency will be there. And then cyber security risks, that is jamming, spooking, hacking, everything is there, and it is very highly costly. Even right now our normal tariffs are only increasing day by day. Just imagine you're using a satellite communication, just imagine the prices, okay. That's it for today. I know I'm being little slow, but I'll make sure I'll come into pace. Okay, I'm actually not feeling well. Every day I'm having cough and all, so I'm unable to record the classes. That's the only reason. Okay, so thank you for staying even till today. I really would love to keep up your expectations, and I will really do. Thank you so much, and have a great day.